I want to start my story in Germany in 1877, the mathematician named George Cantor. And Cantor decided he was going to take a line and erase the middle third of the line, and then take those two resulting lines and bring them back into the same process, a recursive process. So he starts out with one line, and then two, and then four, and then 16, and so on. And if he does this an infinite number of times, which you can do in mathematics, he ends up with an infinite number of lines, each of which has an infinite number of points in it. So he realized he had a set whose number of elements was larger than infinity. And this blew his mind, literally. He checked in the sanitarium. And when he came out of the sanitarium, he was convinced that he had been put on Earth to found transfinite set theory because the largest set of infinity would be God himself. He was a very religious man. He's a mathematician on a mission. And other mathematicians did the same sort of thing. Swedish mathematician von Koch decided that instead of subtracting lines, he would add them. And so he came up with this beautiful curve. And there's no particular reason why we have to start with this seed shape. We can use any seed shape we like. And I'll rearrange this, and I'll stick this somewhere down there. Okay. And now upon iteration, that seed shape sort of unfolds into a very different looking structure. So these all have the property of self-similarity. The part looks like the whole. It's the same pattern at many different scales. Now, mathematicians thought this was very strange because as you shrink a ruler down, you measure a longer and longer length. And since they went through the iterations an infinite number of times, as the ruler shrinks down to infinity, the length goes to infinity. This made no sense at all. So they consigned these curves to the back of the math books. They said, these are pathological curves, and we don't have to discuss them. And that worked for 100 years. And then in 1977, Benoit Mandelbrot, a French mathematician, realized that if you do computer graphics and use these shapes he called fractals, you get the shapes of nature. You get the human lungs, you get acacia trees, you get ferns, you get these beautiful natural forms. If you take your thumb and your index finger and look right where they meet, go ahead and do that now, and relax your hand, you'll see a crinkle, and then a wrinkle within the crinkle, and a crinkle within the wrinkle within, right? Your body is covered with fractals. The mathematicians who were saying these are pathological, useless shapes, they were breathing those words with fractal lungs. It's very ironic. And I'll show you a little natural recursion here. Again, we just take these lines and recursively replace them with the whole shape. So here's the second iteration, third, fourth, and so on. So nature has this self-similar structure. Nature uses self-organizing systems. Now, in the 1980s, I happened to notice that if you look at an aerial photograph of an African village, you see fractals. And I thought, this is fabulous. I wonder why. And of course, I had to go to Africa and ask folks why. So I got a Fulbright scholarship to just travel around Africa for a year asking people why they were building fractals, which is a great job if you can get it. And so I finally got to this city, and I'd done a little fractal model for the city just to see how it would sort of unfold. But when I got there, I got to this palace of the chief, and my French is not very good. I said something like, I'm a mathematician and I would like to stand on your roof. But he was really cool about it. He took me up there and we talked about fractals. And he said, oh yeah. We know a rectangle within a rectangle within a rectangle. We know all about that. And it turns out the royal insignia has a rectangle within a rectangle within a rectangle. And the path through that palace is actually this spiral here. And as you go through the paths, you have to get more and more polite. So they're mapping the social scaling onto the geometric scale. It's a conscious pattern. It is not unconscious like a termite mound fractal. This is a village in southern Zambia. The Baila built this village. It's about 400 meters in diameter. You have a huge ring. The rings that represent the family enclosures get larger and larger as you go towards the back. And then you have the chief's ring here towards the back, and then the chief's immediate family in that ring. So here's a little fractal model for it. Here's one house with the sacred altar. Here's the house of houses, the family enclosure, with the humans here where the sacred altar would be. And then here's the village as a whole, a ring of rings, with the chief's extended family here, the chief's immediate family here. And then here, there's a tiny village, only this big. Now you might wonder, how can people fit in a tiny village only this big? That's because they're spirit people. It's the ancestors. And of course, the spirit people have a little miniature village in their village, right? So it's just like George Cantor said, the recursion continues forever. This is in the Mandara Mountains near the Nigerian border in Cameroon, Mukulek. I saw this diagram drawn by a French architect, and I thought, wow, what a beautiful fractal. So I tried to come up with a seed shape which, upon iteration, would unfold into this thing. I came up with this structure here. Let's see, first iteration, second, third, fourth. Now, after I did the simulation, I realized the whole village kind of spirals around, just like this, and here's that replicating line, self-replicating line that unfolds into the fractal. Well, I noticed that line is about where the only square building in the village is at. So when I got to the village, I said, can you take me to the square building? I think, something's going on there. And they said, well, we can take you there, but you can't go inside, because that's the sacred altar where we do sacrifices every year to keep up those annual cycles of fertility from the fields. And I started to realize that the cycles of fertility were just like the recursive cycles in the geometric algorithm that builds this. And the recursion in some of these villages continues down to very tiny scales. So here's a Nankani village in Mali, and you can see you go inside the family enclosure, you go inside, and here's pots in the fireplace stacked recursively. Here's calabashes that Isa was just showing us, and they're stacked recursively. Now, the tiniest calabash in here keeps the woman's soul. And when she dies, they have a ceremony where they break this stack called the Zalanga, and her soul goes off to eternity once again. Infinity is important. Now, you might ask yourself 3 questions at this point. Aren't these scaling patterns just universal to all indigenous architecture? And that was actually my original hypothesis. When I first saw those African fractals, I thought, wow, so any indigenous group that doesn't have a state society that's in a hierarchy must have a kind of bottom-up architecture. But that turns out not to be true. I started collecting aerial photographs of Native American, South Pacific architecture. Only the African ones were fractal. And if you think about it, all these different societies have different geometric design themes that they use. So Native Americans use a combination of circular symmetry and fourfold symmetry. And you can see it on the pottery and the baskets. Here's an aerial photograph of one of the Anasazi ruins. You can see it's circular at the largest scale, but it's rectangular at the smaller scale, right? It is not the same pattern at 2 different scales. Second, you might ask, well, Dr. Eglash, aren't you ignoring the diversity of African cultures? And 3 times the answer is no. First of all, I agree with Mudimbe's wonderful book, The Invention of Africa, that Africa is an artificial invention of first colonialism and then oppositional movements. No, because a widely shared design practice doesn't necessarily give you a unity of culture, and it definitely is not in the DNA. And finally, the fractals have self-similarity. So they're similar to themselves, but they're not necessarily similar to each other. You see very different uses for fractals. It's a shared technology in Africa. And finally, well, isn't this just intuition? It's not really mathematical knowledge. Africans can't possibly really be using fractal geometry, right? It wasn't invented until the 1970s. Well, it's true that some African fractals are, as far as I'm concerned, just pure intuition. So some of these things, I would wander around the streets of Dakar asking people, well, what's the algorithm? What's the rules for making this? And they'd say, well,